if you were to look, the Antarctic is actually a little bit below normal. Now, the Antarctic is sort of a small place, and it changes a lot, but it's actually below normal. But if you start running along, the southern hemisphere, which includes the Antarctic, is well above normal. The tropics are well above normal. The northern hemisphere, coincidentally, it's the same anomaly. The northern hemisphere, which includes us freezing our buns off, is well above normal. The Arctic is a little changeable place, but it's way stinking hot above normal. And the world as a whole is above normal. Now, there is a technical scientific term for what happened here in Pennsylvania today. It is called weather. And it is indeed true that we have cold weather. And yes, I was careful about my nose this morning, but be very clear that we have less cold weather than we used to. And the number of record lows has gotten very small, the number of record highs has gotten very big, and the world is warming. So even you say, oh, it's a cold day in heck, why are we worried about global warming? I'll try to show you here in a minute. Okay? So with that as background, how many of you have taken Geosciences 10? Geology? Yay! All right. So I'm going to talk, the rest of you who haven't, I'm sorry, you should have done so I'm going to show you a little story on how much value we get from our energy system. And then I'm going to show you why we have to get to a sustainable one. And then I'm going to show you how we can do so to help the environment, the economy, and the ethics. So that's where we're going to go. And this comes from this story we did. So when we started Geology of the National Parks, Geosciences 10, we got a dozen advanced students. Great people. We got WPSU to teach them how to do video. And we took them to the bottom of the Grand Canyon. So here they are hiking it down to the bottom of the canyon in moonlight. And so we had a ball. Okay, this was just great. They filmed the parks. We wrapped a course around this. We took WPSU along. They filmed the students filming the parks. They won a regional Emmy from that. And it was just so here's Stephanie telling Topher why the river is now clean when it used to be muddy. And the river is now clean because the mud is trapped on the other side of the dam. And here we are rafting down the river. And this is geology of the national parks, right? It's geology. But of course, you're driving right by Mesa Verde. How many of you have been to Mesa Verde? Yeah. The rest of you, put it on your list. It's fantastic. It's down in southwestern Colorado. And these native Puebloan people lived on top of this beautiful mesa for hundreds and hundreds of years. And they built these fantastic buildings down the sides of the mesa. And then they left. And so I'm going to tell you a story about them. They're people. I'm going to tell you later, CO2 is a greenhouse gas. CO2 is a greenhouse gas. And no, there isn't anything to argue about. Nothing. Okay? I'm going to tell you a story about people. I guarantee you that they are more interesting and more nuanced than what I'm going to tell you. You can never put people accurately in 10 minutes. But what I am going to tell you, I believe is accurate. It just is not the full story. That story is much more interesting than this. But at any rate, let's walk through it. So if you've not been there, so they lived on top of this mesa, and they grew corn and other things up there, and then they built their houses down the sides. And they're these beautiful houses. It's just amazing, in crazy places. You just can't imagine getting there. But I want you to notice this thing up at the end of the blue arrow. And it's the same thing up at the end of that blue arrow. Now for scale, this is one of our students down here. So there's a person for scale. Here's a ladder to move around. And notice this thing. Now, probably none of you have gotten to this. But the day will come when you've got the package of Oreos, and you've got the gut, and you say, you know, I just can't eat all of these Oreos. I'm going to put them up on the top shelf, and then I'm going to put the ladder away, and then I won't eat them. Okay, this will happen to you someday. I'm sorry. But the difference between us and them is that that's not the dessert, that's the dinner. That's your main course, and they're putting it where you can't get to it. And that's telling you something. Nobody puts the main course up where it's on the cliff and you have to do special things to get to it, but they did. Now, if you go behind those caves, the buildings, they're built in caves. The caves are there for geological reasons, and a little bit of water seeps out. And if you go right at the end of my blue arrow and look down, you see these holes. Somebody sat there with a rock and chipped a hole in the floor, and water puddles in there. Now, it is not quite as nice as what's in the back of the room here, I can tell you. But if that were all the water in the world, it might be worth chipping a hole in the floor to get a drink. You look in these buildings, and they have walls, and the walls had windows, but the windows are walled off now. They built these walls with windows. And then later they went back and did a lot of work to put rocks in the hole. Now when you block off a window, you are blocking something out. And what are they blocking out? The other side of this is their neighbors. And they are walling off their neighbors, which is not exactly what you do in a happy, healthy, terrific place. Up on top, if you want to go see these stone ruins, you walk past this. They built this 500 years ago, 600. And it stops a little bit of erosion, and it traps a little bit of dirt and a little bit of water, and this was a cornfield. And if you're hungry enough, every little bit of dirt is a good thing, because you can grow a little bit of corn. And then, after living there for centuries, they left. So it's very clear when you look at this that this was a hard life in the very best of times. And it looks really bad at the end. Walling off your neighbors, putting the food up there, trying to find a little bit of water and a little bit of food, and then they bail out. So let me now walk you through a little science. I did not do this science, but it's closer to what I do. This is stone. There's not much wood out there. They were growing corn, not trees on top. But there's a little bit of wood. And if there's wood, there's tree rings. And if there's tree rings, we can do science. So you know that you can count rings in a tree. And some of them are fat and some of them are skinny. And you can match the pattern of thick and thin rings to make a record that is longer than the life of one tree. And you can go into archaeological sites, you can go into dead wood, and you can make a longer record. In this very dry environment of the Southwest, a tree is happy when it rains. And so the thickness of a ring is a rain gauge, and the pattern of rings lets you match and make a record of rain. So what they did, you would not do this study at Mesa Verde. It's a big place with a lot of trade. They went down from Mesa Verde to a place called Longhouse Valley, and they did a very interesting study. One group of scientists reconstructed the rain. And then they talked to anthropologists who talked to native Puebloan people, and they said, how much corn can you grow with that much rain? How many people can live on that corn? And beans and squash. And so how many people could have lived in Longhouse Valley as a function of time because of the rain? And then independently, a completely different team of scientists goes in and they do classic archaeology. Who's buried here? How many people were cooking things? How many people did live here based on the remains they left? How many people could live here? How many people did live here? Independent, estimated in two very different ways. How many could live? How many did live? And here it is. So the year 800 is over here on your left. The year 1300 is over on the right. And it doesn't matter what color is what color. Within the uncertainties of the method, how many people did live there and how many people could live there are the same. When the rain came, the people came. And over centuries, as the rains came, the population rose. When the rains dropped, maybe some people left. Maybe they didn't have as many babies. Maybe their babies died. There's not another choice. The population fell when the rains didn't. And the rains came back and the population came up, and then the crash hit, the drought hit. And at some point they could have had a few people hanging on, but they said, screw it, we're out of here. They became environmental refugees and they left. how many people could live there, how many people did live there was the same. And when it didn't rain, they left or they died. And there isn't another option. Okay. Now, let me show you a different take on the same story. Anybody read The Grapes of Wrath? Yeah, okay. So you know the story. We have a drought in the 30s. We have a depression in the 30s. A lot of people in Oklahoma get in their cars or other things and they head for California. But now they're running away from the dust. They're running away from the drought. But they have trucks. And they have electric lines. And their trains can bring them food. And there are diesel well drilling and pumps that can get water out of the ground. And so a lot of people left, and we have this mental picture of everyone fleeing Oklahoma for the Golden West. This is the same plot. I changed the colors, but 1900 is on your left, over towards today is on your right. The red is essentially rain. There's a Palmer Drought Severity Index, but it's essentially rain. And this is the Dust Bowl right there. Big drop, and you'll notice there's some others since then. So there's the Dust Bowl. Black is population of Oklahoma. Now, all those stories, all the Steinbeck, all the movies of everyone fleeing Oklahoma, here's the Dust Bowl and there's the population. This is actually World War II. A lot of people going off to save the world. But what did the Dust Bowl do to population? It stopped the growth. But they didn't die. They actually hung on. And the difference is those trucks and trains and wells and pumps and a bunch of other things. Now, I can guarantee you that Oklahoma is full of smart people who did good things. I can guarantee you that Mesa Verde was full of smart people who did good things. If they dropped us on the top of that mesa and said, you get through the winter, trust me, none of us would. Okay? But Mesa Verde didn't have the tools. They didn't have the power. And when the climate went against them, they lost. And Oklahoma did, and they got by. And so the difference is really knowledge and tools, power, things to power them. I have a different talk I can give you someday. The world was probably overpopulated with a few million hunter-gatherers. We are a few billion learn, teach, read, write, build growers. If we tried to go back to the way our ancestors did it, the next 1,000 people you meet, maybe one survives. Okay? Knowledge is completely essential. The idea that we're all going to go back to shooting deer and eating acorns is completely absurd. Our knowledge is the thing that keeps us here. And you are a little piece of that as teachers, and you are a very important piece of that. We could walk through this someday. You got your cell phone on you, right? What's a cell phone? What is a cell phone? Right? At some point I asked this in a schoolroom, and I said, what is this? You know, what's it made of? Finally, this bright student sitting there gets uncomfortable. You know how it is in the room when you ask them and they don't have an answer, and they're saying, cell phone parts? Say, yeah, what's a cell phone part made of? Right, it's a little bit of sand for the glass and the silicon, and it's a little bit of oil for the plastic, and it's the right rocks, the ones with the rare earth elements and the copper and the gold. It's sand, oil, and rocks. Right? I'm sorry, may I borrow yours for a moment?
Yeah.
Thank you. Sand, oil, and rocks. And science and engineering and design and marketing. Right? Einstein's in here. The GPS has relativity in it. And if it didn't, it would get lost. And Heisenberg's in here. The design of the computer has quantum mechanics. And Wegener is in here. We use continental drift to figure out where the right rocks are. Right? This is science. And engineering and design and marketing. It's fantastic. Thank you. Okay, so the question is, we have come from a few million hunter-gatherers to a few billion of us who are way better off. And the question is, how do we keep that going? And of course, that's going to be sustainability. And I'm going to talk especially about energy. So there are many issues in sustainability. Energy is not the only one, but I'm going to do this one because it's probably the single biggest one. The UN says it's food and energy, but a lot of food is energy. So here's the numbers. I don't know, there was a roll back there that had some cheesecake in it. If you got that one, you may be over your 2,000 for today. But at any rate, what do we do? Our food is 2,000 calories per person per day in round numbers. We did not cook the food. We did not plow the field. A diesel tractor did. We did not truck it to us. I jog in, I ride my bicycle. I don't ride my bicycle out in the country and pick up a hog so I can have bacon. Right? So all of these, and we love these, it's great. Energy use in the US economy divided by the number of people and turned into these units is 240,000 calories per person per day. 2,000 is what you can do for yourself, 240,000 is what's done for you. It is a little over 100 serfs to do your bidding. Whatever you can do for yourself is 1% of what's done for you. Right? If I were actually to ride a bicycle, hooked to a generator, to power the projector and the computer, and maybe 1 or 2 lights, I would be out of breath. That's all I could do. And it's fantastic, and it's about 85% fossil fuel, and we love it. This is a fantastic thing for us. Okay? I'm going to walk you through a little history. We have a long history of finding something we could burn to get energy, burning it way faster than nature makes more, having a crisis, and then looking for something else to burn. And I'm going to show you this, and we're part of this story. So you are here because of this. And this, which would have looked more like this when it was running, was turning red dirt, limestone flux, and charcoal into Juniata iron, and the east was built of our iron. And when it was running, there was a city of 100 people taking care of it. And so we were built by the iron masters up the hill from the iron furnace. The people sort of lived down where Noble Marsh is now and on down East College. There was probably a water wheel to drive the blast. It's there where the duck pond is. East College down there is actually built on a lot of slag. You go down and look carefully, you'll find the green glass that came from the furnace. They just bulldozed right over it and built this. And the charcoal came from trees. And they made it like this. You make a pile, you cover it with dirt, you burn it with only a little oxygen, you drive off stuff, you take what's left, and you use it as power for the furnace. And this is what it did to the landscape. Okay. A furnace in blast took a little over a half a square mile of trees for a year. And there's 100 people taking care of it. And they have houses, and they cook, and they heat. So you can figure a furnace, when it was working, was a square mile of trees a year. Now, if you today get online, you go to a Gazetteer of Pennsylvania, and you ask, where are the places that we still remember the name furnace? We haven't forgotten. Where is furnace still on the map? These are the furnaces. Each one of these, and a bunch more that aren't on here anymore, when it was working, was a square mile of trees per year. These are the forges, Valley Forge and a bunch of others. You turn the pig iron into useful things, another square mile of trees per year. And the trees were gone. Right? This is Pennsylvania. We are Penn's Woods. When the first European settlers got to the shores, they said a squirrel could go up a tree on the Atlantic coast and stay in the trees to the Mississippi. The first forester of the Commonwealth was a fellow named Rothrock, of Rothrock State Forest. He wrote about the Pennsylvania desert. Now, it wasn't a desert, but there were no trees in Pennsylvania. A few here and there, but they were gone. There are 1 million deer in Pennsylvania now. There were essentially no deer. We have elk because we re-imported them from the Rocky Mountains. We chased out the elk, we chased out the bison. Basically, everything bigger than a rabbit, we chased out. The turkeys were basically gone, the fishers were gone. Were the Nittany lions? There's no Nittany lions. You know, there were mountain lions. Well, there was nothing to eat, and there wasn't a tree to do it behind. we cleaned it out. And the trees simply did not grow back fast enough to be useful. Now, if you've ever tried to read by firelight, it's hard. If you've ever tried to do 12 stitches per inch in a quilt by firelight, that's not easy. What do you do to see? Candles are not much better. They used to use a biofuel called camphene, which is a mixture of alcohol and turpentine. It burned clean, it was cheap, but it tended to blow up. It's like white gas. And there's horrible stories of, the Methodist minister and his wife go out to visit the parishioners, and they leave the daughter's home, and the daughters try to refill the lamp, and they burn themselves to death. And the rich people used to cook whales and burn them. So you send Yankees out to kill whales, you cook the oil out of them, and you use that, and it's clean, and it doesn't stink, and it doesn't blow up. And this, from 1800 to 1880, is a history of whale oil from the Yankee fleet. Right here, there are 10,000 sailors on ships out of New England chasing whales. 10,000. Now there's a civil war over here, and the fleet gets crushed in the sea ice off of Alaska, and the insurance rates go through the roof. But what's the fleet doing in the sea ice off of Alaska? There were no whales closer that they could catch. They had used them. And so this is price. Peak whale oil hits. This is $7 a gallon in modern money. Peak whale oil hits, and not when you ran out of whales, but when you half ran out of whales, it goes to 23 bucks a gallon for whale oil. And then what happens? They go right up the road here. Oil is leaking out of the ground. Some bright person says, wow, if oil leaks out of the ground, maybe there's oil in the ground. And they drilled the first modern oil well. The numbers. 100 years of Yankee whaling, 10,000 sailors at the peak. The total amount of oil is about a week of recent oil imports. 1 week for 100 years. The idea that we go back, we start cooking whales again, is absurd. Okay? But we have whales and trees because we switched to burning fossil algae and fossil trees. And it is that simple. We have whales and trees because we switched to burning something else. And they knew this a long time ago. In the back, you can't see this. This was published in the year of Vanity Fair in the year 1861. It is the grand ball given by the whales in honor of the discovery of the oil wells in Pennsylvania. So the whales here are toasting the oil wells of our native land. May they never secede. Right, just before the Civil War. Oil's well that ends well. We have whales and trees because we switched to doing something else. And we have to change. The fossil fuels accumulated over a few 100 million years. We are burning them over a few 100 years. We are burning them 1,000,000 times faster than nature saved them for us. It is not a choice. Do we do fossil fuels or do we do a sustainable system? We either learn while we burn or we burn and then learn, but there's no third option. The easy stuff is already gone. The oil was leaking out of the ground, and now what are people doing? They're fracking way down deep. They're going out in the deep water of the Gulf. They're going wherever they can because the easy stuff's gone already. There's a lot still there. We haven't taken off all the mountaintops yet. But it's once you take them off, it's gone. And so there is not a choice between fossil fuels and renewables. It's just how fast we head towards a sustainable future. Because they will go. We burn whales faster than they grew back. We burn trees faster than they grew back. We're burning fossil fuels lots and lots faster than they grow back. Okay? The numbers. How good fossil fuel companies are at getting us what we want is flabbergasting. Okay? What we throw away, there's a trash can over there, there's some recycling, there's a trash can. What we throw away at the curb for trash per person per year in the US is 1,000 pounds, half a ton. When we burn fossil fuels, we make CO2. What we put in the air is 20 tons, 40,000 pounds per person per year. You throw away 1,000 pounds of trash per year each. and 40,000 in the air. 1,000 in the landfill, 40,000 in the air. Now, that 40,000 in the air is going to change the climate. And we have known this before Einstein did relativity, before Wegener did continental drift, before Heisenberg did quantum mechanics. This was known. And a lot of it was really worked out by the Air Force right after World War II for things like heat-seeking missiles. If your job is to make sure the enemy doesn't bomb your city into oblivion, the hot engine of the enemy bomber emits infrared radiation. You can follow that. You can fly up their tailpipe and make sure they don't get to your city. But if you put the wrong sensor on, it doesn't work because CO2 soaks up that energy, spreads it through the whole atmosphere, and you can't see what you're shooting at. If you go out today, even today, on a cloudy day, on a cold day, the sun heats the Earth sends the same sort of infrared radiation back to space, and CO2 absorbs it. And today, there is more energy going up from the sun-warmed Earth than coming down from enemy bombers. This is a picture from a satellite looking down at the Earth. This is the energy going out from the sun-warmed Earth. This is CO2 absorption. This is measured fact. If we add more CO2, it absorbs more. People say, do you believe in global warming? There it is. Okay. So we don't believe in global warming. It arises from unavoidable physics. There's no serious debate about this. There's no serious discussion. In particular, there is not another side. A lot of people have spent a lot of money to convince you that there's another side. Science is what we know. There are people who think I'm too alarmist on this. There are people who think I'm not nearly alarmist enough on this. But the basic physics, there's nothing to discuss. It's physics. And someday we'll understand it better. And we'll figure out how it relates to gravity and gravity waves. But this is very, 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 very unlikely to change. It's physics. Now, if you come and take a class, if you read the book, if you watch TV shows, if you get into this in a little more detail, we can walk you through the whole story. Fossil fuel burning is raising CO2. This has a warming influence. It is getting warmer. And it is getting warmer despite the fact that over the last 30 years, the sun has actually gotten a little dimmer. You'll hear people say, oh, it's the sun. No, it's not. The sun has gotten dimmer. And the temperature went up anyway. We have blocked the sun with our particles. Volcanoes have blocked the sun with their particles. We have cut dark trees and replaced them with more reflective grasslands in places like Brazil. And yet, despite that, it has warmed up. The central estimate over the last 30 years, how much of the warming is from our greenhouse gases? More than 100%. Somebody says, I'll compromise. I'll admit it's getting warmer, but how much that's human? More than all of it. Because recently nature has tried to cool it off a little. Okay? The compromise doesn't get you anywhere. All right? More than all of it. And what this does is tell us if we frack it all, if we take off all the mountaintops, we can raise CO2 a lot more, and that will have an influence. So what does it do? I'm going to walk through a couple of these, right? So sea level rise is what we work on a lot. That's almost unavoidable. You don't have to get malaria or Zika, but you lose one defense, which is right now those things only go as far as the mosquitoes do, and when it gets too cold, like today, they get frozen to death. When you lose freezing them to death, they can spread. And we'll hit a few of these others. More variability in the water system, more floods and more droughts. That actually does work. And we'll come back to costs rise faster than temperature. Let me hit this one, okay? This is a paper that was published last summer in the Proceedings of the National Academy of Sciences. This agrees with many other papers. And I'm going to it's called Climate Change in the Fertile Crescent and Implications of the Recent Syrian Drought. Right? Thanks for mentioning this. And let's pull this out and blow it up. Drought contributed to the conflict in Syria. It was a very unhappy place in many ways, but then it didn't rain, and the crops died, and hungry people moved to the cities, and then they got really unhappy, and then it blew up. Humans have made the probability of that drought 2 or 3 times more likely. Did we cause it? We made it more likely, and it happened. We weighted the dice to bring the drought. Okay. Did we cause ISIS or ISIL? No. Did we make them more likely? Pretty clearly. Okay? Now this, we're going to zoom in here. If we keep burning into the future, green is less drought. Reds and yellows are more drought. And I'm going to zoom in over here. And what you see right there is reds. A place where we have already made drought more likely, and people have gotten really unhappy, and things have sort of blown up in very unpleasant ways. If we keep doing what we're doing, we will make drought a lot worse there. And our military leaders, including Rear Admiral Tetley down the way here, but our military leaders have traced these dotted lines that lead from drought to civil war in Syria, that lead from heat and drought in Russia and China to the uprisings in North Africa. And the way they put it is this. They say climate change alone did not cause the conflict. It certainly added environmental stressors. In unhappy places, making them more unhappy doesn't help. And our military leaders know this. This one came out a little while ago from the World Bank. It's not this week now. It was last fall. I need to change that, sorry. But at any rate, climate change could force more than 100 million people into extreme poverty by 2030. And people who are being forced into extreme poverty by 2030 tend to get up and move somewhere else and try to get across borders, or they tend to get mad at somebody or something like that. Okay. We are a little bit cold today. And you might be happier if it was a little warmer. In the summer, you might wish it was a little cooler. This is a paper that just came out that is broadly similar to a number of other studies. If we turn up the temperature, what happens to the economy? Blue is actually the economy gets a little better with warming. These places are so cold that making them warmer actually allows more economic activity. Pink and red is the economy gets worse with warming. What you will notice is that there are some places up here that are blue. Right? Siberia, economically, it changes native lifestyles, but they might like it a little warmer. We're not very red, we're only pink here. But then you see all this red down here. Almost all of the world's people, and most of the world's area, lives in places where warming hurts the economy. Remember, this projection doesn't show it, but the world gets smaller towards the poles. So in principle, yes, maybe all these people can go up here to live, but this is smaller than it looks. And the soil from up here is actually down here because the glaciers brought it down. And there's a whole bunch of borders between these people and this place. And if you've ever seen what's going on in modern discussions of immigration, crossing borders is not as easy as one might think. So basically, all the world's people are in places that this one says the economy gets worse when it gets warmer. Right? So who's changing the economy? Red is changing the economy a lot. Blue is changing it a little. Who suffers? Red is suffering a lot. Blue is suffering a little. Red changes the economy. Red suffers from the changing economy. If those two maps do not look the same to you, and you believe in the golden rule, right? So Pope Francis looked at this, and he said, it seems clear to me also that climate change is a problem which can no longer be left to a future generation. Pope Francis really hates this map. And I think a whole lot of us do too. Okay. Oh, sorry. This, by the way, if you're worried about drought in Pennsylvania, the blue up here is less drought in the future projection, but we're in more drought, and down here is a lot more drought. And the Mesa Verde is right here, more drought. Okay. This one's really important. Costs go up faster than temperature. First degree of warming, yeah. We've lived in a variable world before, we'll figure it out. But we've already had that. Now, I did contribute to the problems in Syria, but it's the cheap one, okay? The second degree of warming, you start moving outside of what you're used to, but you can learn from people in hotter places, and we're pretty well committed to that one. The third degree of warming, you start getting places on Earth that they can't look to somewhere that's warmer to get new crops, because there's nowhere warmer. And when you can't borrow a crop from somewhere warmer that likes the warm temperatures, your yield goes down. And then you get hungrier. And that's the one we're talking about, is 3, 4, and 5. Now, these are Celsius, so, so 2 Celsius is 3.6 Fahrenheit, but the land warms more than the ocean, so it's 5 Fahrenheit or something like that. So what we're arguing about now is 10 Fahrenheit, is 15 Fahrenheit, is real numbers. Okay? And that's really, the decisions we make now will determine whether we go to there. Okay? So, recent hearings on Capitol Hill have emphasized the uncertainties. You're scientists, you don't know everything, right? Okay, that should make you very nervous. You know that you couldn't borrow your phone again. You know darn well you couldn't build this with a hammer. And you know darn well you could break it with a hammer. Building things takes getting a whole lot of stuff right. Breaking things can be done in a whole lot. You could break that with a hammer, you could break that with a steam shovel, you could break that with a steam roller, you could break that by heaving it off the top of a building, you could break that by throwing it in a pot of oatmeal, you could break that in a whole bunch of different ways. Okay, but building it takes getting everything right. If you just crank up CO2, what are the odds that it turns the planet into the Garden of Eden? Pretty low, because that takes getting a whole bunch of things right. But if you make it too hot for your crop, it can die. And too cold can die. And too wet can dry. And too dry can die. And you don't have the pollinator at the right time, it can die. And you bring in a competitor, or a rust, or a smut, or a bug that eats it, and it can die. And so you look at the uncertainties, and it might be a little better than we think. It might. And it might be a little worse than we think. But it might be a lot worse. And the mere knowledge that building is harder than breaking tells you in your common sense that just cranking up CO2 and changing the climate, if you don't believe science, you ought to be scared, because you're making a big change. What's the worst thing that could happen, by the way? By late in this century, it starts to become fatal outside in some parts of the world if we keep burning. So you know, on a really hot day in the summer, if you're locked in a car, you don't lock your puppy in the car when you go into the store, because he'll die. Right? It could become hot enough by late in this century that you go outside in parts of the world and you die. You're locked in a car you can't get out of. Okay? So now we're going to get to the good news, right? So if we deal with this, not only do we get a cleaner environment and help our grandchildren, but we get a stronger economy, we get more jobs, and so on. So this might be a 30-year change. Think 30 years. I'm 58. I'm through 2 of those 30s already, almost. I probably get 1 more. I could live to see this be done. Okay? So we'll do this. This is where we grow our food. This is where we let grass grow and animals eat it and then we eat them, or something that comes from them. The 2,000 calories per person per day that we eat comes from the colored areas on these 2 maps. That is how much of the land we have changed to feed us. Suppose that we decided with shovel-ready, off-the-shelf, commercially available solar cells to build a solar farm that would give more energy than is now used outside of all the people on Earth. How much more would we have to change? These colors are what we have changed to feed us, those 2,000 calories per person per day. The area to supply more energy than we now use outside of us in the whole world is right there. Now, don't kid anybody. That is a huge number of solar cells. If you start thinking of that big, and no one's going to build it there, right? A lot of it's going to be here, and some of it's going to be here. But just for the scale, we have happily changed everything else in color on here to feed us, and that much more would power us. And yeah, what you're gonna do is you're gonna put solar cells over the parking lot out here at Beaver Stadium, and when you come in the summer, you're gonna plug in your car, and when you go home, it's gonna be charged, and it won't be hot because the sun is going to power your car rather than make it hot. But that's the scale. Now, this is from our TV shows. Abe Lincoln, before he is president, is running around giving a speech on why we need knowledge and learning and teaching and inventing and patents, and he says we need wind energy. He says the wind is an untamed and unharnessed force, and one of the greatest discoveries to be made will be the taming and harnessing of it. If we put a wind farm on the windy parts of the plains and deserts of the world, that is about 5 times more energy than humans use. You don't have to go in the water, you don't have to go in the forests. The windy parts of the plains and deserts of the world is far more energy than we use. Okay? And when we filmed it, these Texas ranchers, some of them don't believe this climate change stuff. But boy, do they believe in wind. They call it mailbox money. Right? So they go out to the mailbox and they get money. They get $5,000 or more per year from each one of these. So you put 5% of the ranch in wind turbines. You leave 95% of the ranch in what you used to do with the ranch. But this pays a lot better than this is, and this is actually a lot easier than this is. Okay? And it has been so successful that there is now a company in Dallas that gives, if you run your clothes dryer at night, it's free. They turn off the meter. Because there's so much wind energy on the grid that, yeah, it's free. Have fun. Okay, right, so we can get 100 times more energy than we get from food on a much smaller area. We can quit emitting that 40,000 pounds of CO2 apiece that dwarfs our 1,000 pounds of trash. We can help the economy doing this. It might take 30 years, but you know, you're going to live a couple of 30 years as yet. Maybe 3. All right. So, and you go back in here, and when we switched to farming and learning how to do it right, we actually saved a whole lot of lives. But we haven't yet done that with energy. We're still hunter-gatherers of energy, and the transition is now possible. No, when I was a student, we would have said we could learn how to do this, but we don't know how yet. When you're students, we know how. And you have electric utilities now are working very hard to try to figure out what to do with wind and sun because they've gotten cheap enough that they're upsetting the business model. We know how. You are the first generation in the history of the world that knows how to farm energy in a way that is economical and sustainable and will give everybody power essentially forever. And we've never known that before. So, let me leave you with a picture I took in Greenland years ago. Can we have a world with icebergs and rainbows? Of course.